Okay, we'll have the same sort of format as before. We'll have questions and comments from our panel members. We have an expert in the area of seismicity, Steve McNutt, and he may have some stuff that he, some prepared material that he would like to show as well. So let's go ahead and start again at the far end with.
Well, maybe let Steve start.
You want to let Steve start? Steve, are you ready?
The ordering of the presentations was volcanism first, then seismicity. Do you care to follow that same order? Or?
Does it matter to you, Graham?
I'm fine.
Either way, yeah.
If you want to do volcanism first, it might be better because it probably doesn't generate as much volcanism.
Okay, I have a question. You talked a little bit about Augustine and Redoubt and Iliamna, but there was no mention of other volcanoes further down on the Alaska Peninsula. Katmai volcano, which we just went through the 100-year anniversary of the 1912 eruption, which was the largest eruption in the world in the 19th century. No mention of that. Also, Aniakchak caldera produced an eruption about 3,500 years ago that liberated more than 50 cubic kilometers of material, a very catastrophic eruption. And I would expect to find tephra volcanic ash deposits of those two eruptions in the Pebble area. So curious if they had been encountered and what your thoughts are about dealing with activity from volcanoes not mentioned.
Well, the reason I didn't include those volcanoes in the environmental baseline document is because they're just farther away than the ones that are closest. And in terms of controlling a volcanic eruption, you can't really do that. And like ash is probably the most significant hazard to the project, but there's virtually nothing that you can do about it.
But there would be mitigation measures put in place to deal with the effects of ashfall. This could have some big implications for safety, access, resuspension of ash is an issue. So there are some secondary problems and hazards relevant to even small amounts of ash.
Mm-hmm. Well, those will probably be addressed in later studies. I mean, this was just to talk about the background volcanism in the area. But in terms of how Pebble plans to address volcanic eruptions in the future, I don't think they've studied that yet.
Okay.
Yeah, just to amplify something that Chris said a bit earlier, it is the ones that are to the west that probably pose a greater hazard at that site, and it's because the predominant winds blow from west to east.
Right.
So any of those volcanoes downwind, if they had a significant eruption, if the wind's in the right direction, you got a problem on your hands with a lot of ash being potentially dumped on the site. So that's in some respects, those. Although Iliamna and Augustine are closer, I think the ones that downwind actually pose a greater hazard. So
Okay.
I would have liked to see the report address that, directly and explicitly.
Are there ash deposits in the soil profiles? Sorry, are there ash deposits actually on site that you can see in the soil profiles?
I don't think there's any have been noted yet, but that doesn't mean they're not there.
Somebody this morning said when I saw this presentation that it was a combination of loess and volcanic ash on the site.
Yeah, I'm not sure about specific layers, but yes, certainly volcanic ash is a big constituent of the soil.
Is it reworked, or are there actual ash-fall deposits?
Yeah, I'm not sure about that detail.
Yeah, the 1912 Katmai ash is in the area. It's in Niskin Bay. But the best way to get a handle on how many ashfall events there have been in that area would be to core some of the lakes. Lakes typically provide a nice repository for volcanic ashfall, and we've done this in a number of places throughout the state and have obtained high-resolution records of ashfall. So if you wanted to know specifically how many times ash has fallen, that'd be the way to do it.
Anything else from panelists? Aside from Steve, who I guess has some material.
Some on seismology rather than the volcano.
So does this wrap up our volcanology questions for now, I guess?
I think so.
Yeah. But just to reiterate, the main hazard to the mine site will be ash fall, and that's really it. It's too far for any ground hazards, mud flows, or pyroclastic flows. And if another eruption the size of Aniakchak occurs, there'll be a lot more at risk than just the mine site. So,
Yeah, and these ash hazards, it's not just during the time of the eruption, but the ash can be remobilized by the wind and can present a long-term hazard. The ash is very abrasive, so it can be with you for a great period of time.
right.
Okay. Let's see. Regarding the earthquake presentation, I was pleased to see more detail in your presentation just now than was in the report that I read and evaluated. You pointed out clearly the different sources of the earthquakes, the subduction zone, the Lake Clark fault, other small local faults. One you didn't mention specifically, the dots were there on the map, is what we call the Iliamna Deep Cluster. It's the cluster of deep earthquakes just to the east of the Pebble area. That's actually the most prominent cluster of deep earthquakes anywhere in Alaska. And it produces, if you just do a search on earthquakes within 100 kilometers, most of the events that you'll find are deep events from that cluster, up to, I think the maximum is about 5.5 or 5.6 magnitude. So, I thought you characterized it okay in your presentation. It wasn't mentioned. I don't recall seeing it mentioned in the report, although the dots are there on the map. You also mentioned the subduction zone being the main source of the really large earthquakes, which is true, and the really large ones. We get about 1 magnitude 7 every year somewhere in Alaska, and a magnitude 8 approximately every 10 years. So it's a pretty high rate. Alaska by itself produces about 15% of the world's earthquakes. So that's a take-home point of pride for Alaskans, I think. So as Graham mentioned, those big earthquakes, even though the shaking isn't as hard, it would not be expected to be as hard at the site. They do last much longer time. And again, something I did not see explicitly addressed in the report was the effect of the long shaking. Because the basic questions for seismology is how hard will it shake, how often, and what period. And Graham used slightly different language, but asked the same question. So you try to get the recurrence rate for shaking at a certain level. If you incorporate the spectra that he showed, then you're asking the question. So a moderate-sized earthquake directly underneath the site would shake hard with high-frequency energy. A large earthquake on a subduction zone would shake less hard, but at a much longer period. In fact, there's kind of an upper limit to the strong shaking from earthquakes. The shaking for large earthquakes is not stronger at all frequencies. It's way, way, way stronger at the long periods. And this makes a difference because large-scale structures have a longer natural period. So it's hard. This issue falls into the same region. Some other parts of the investigation at this point is without an idea of the size of the structure, hence knowing what its period would be, it's hard to answer the question about the impact and the likely severities. I'm imagining tailings piles or tailings ponds of different sizes. If you get the right size basin and put the frequency, it's kind of like, you ever get in the bathtub and slide back and forth? You can make the wave as big as you want. And that's the problem. If you have the long duration shaking, even at lower amplitudes, you can set up resonance in the structure. Tailings piles, for example, would have a different response if they're saturated with rains than if they're dry. So this is, again, trying to put a specific structure in there to see what the effect would be. But it does have a bearing on the seismic hazard. Go back to my notes for a second here. So I think that the magnitude 7 is within a few hundred kilometers. Looks like there would be several likely in the life of the mine. This would be the magnitude 7, the regional events, either on the slab or in the vicinity of Kodak and the lower end of the subduction zone. I think you covered those in your presentation. Yeah, the other, so the big take-home message is if the expected shaking would be hardest from the local faults, there were a number of local faults that were mapped and shown on some of the figures in the report, the light blue lines, which are local faults that had little symbols showing up and down motion, mostly normal faults. So you can, it's possible when you do the probabilistic framework, it's possible to assign a likelihood of occurrence to each of those, and you can estimate the source size based on the duration, on the dimensions of the fault. I didn't see exact wording in the report addressing that, although it's obvious from your presentation that the methodology exists. And then the other big one is whether the Lake Clark fault extends onto the study zone. And this is an awkward part of these sorts of analyses, that if you go only by your known and verified information, then you would not include that fault going directly onto the site, because there's no known seismicity on it and you don't see any feature and no evidence that it's moved in the last 10,000 years. But there are other methods. There's the so-called floating earthquake. This is when you don't know and you know that you don't know, you put in a moderate earthquake almost anywhere and you can assign a probability to that and include that in the analysis. I assume something like that would be done.
Yeah, I didn't actually get onto that in the presentation, but it is one of the, I guess I could call it the fourth type of issue, what we're calling the term the maximum background earthquake. And that's a consideration of an earthquake which, by its nature, wouldn't be sort of a magnitude 7.5, it'd be more like a 6, 6.5, maybe maximum, but one that may not show any surface expression of a fault. But we do know that some earthquakes can occur at depth and not show a surface displacement. So that's really the fourth type of earthquake that we would consider.
So has that sort of decision been made about what magnitude would be used for that?
Yeah, so
6 to 6.5?
Yeah.
Okay, that's reasonable. The other thing is, just to mention the geological thing, is the fault has to be vertical or at high angle for its expression to show up at the surface. The other thing we haven't really talked much about is in blind thrusts. Now, I don't know much about geologically whether there are blind thrusts in the region, but there are earthquakes that are basically horizontal, so you wouldn't see the expression on your surface very well. You sometimes see some evidence on the surface of the ground to show that there's relative motion going on. Another thing that, I think I mentioned briefly this morning about the soil thing is most of the region here, it's gently rolling hills, some slightly steeper ridges. The amount of overburden is from a few feet up to about 250 feet, I think, for the various regions. But this is gravel and glacial deposits mixed together. It's basically fairly compact and fairly hard. And this is good news because structures of this sort don't have a very strong natural resonance. The poster child for this is a lake bed in Mexico City. So you have subductions on earthquakes. There's soft sediments where Mexico City is built. The soft sediments themselves have a natural period of vibration. So when you put energy in at the same period as the natural resonance, it's like a kid on the swing, the motion gets very, very strong. That's why Mexico City keeps getting taken out by earthquakes, even though the earthquakes are 100 kilometers away. That seems not to be the case in this region. At least I don't see any evidence in what's been presented so far. Although it's possible there are certain isolated places where there is such effects.
Yeah, I mean, certainly that's a consideration, though, that sort of resonance effect or potential site amplification through overburden. I mean, that's always a consideration. I think, we're going to the next level now where we take these inputs, which are essentially on rock, and then say, okay, depending on where your structure is situated, what's the site-specific information in terms of the topography and the overburden, and how does that have an impact on the ground motion? Does it amplify it or whatever?
And then one other thing, this is a slightly philosophical, I suppose, but I didn't like seeing the maps sort of cut off and locked into a fixed time period. These days, seismic data are plentiful. There are agencies whose reason for existing is to put information about location and magnitude of earthquakes on the web almost as while the ground is still shaking. So I'm just thinking the best example of that is northern Japan. Suppose you had a time frame from 2004 up to 2008 or say 2010, you would have completely missed the magnitude 9 earthquake that occurred in March of 2011. So it means that information in seismology is dynamic, and you have to allow your framework for evaluation to be dynamic as well. So you want to have figures that are easily updated to incorporate the new information as it's coming in. And then this also, for each of these parameters that we've been discussing, it's not so much that you're after a fixed value, but there's a range of values, and you need to define the variance. I took a look at some of the earthquake rates. The earthquake's magnitude 3.5 or so and larger varied from a low of 8 to a high of 34 in 1 year. So this is just natural background variations. You don't just get a single fixed value, but for each of these you need a variance. And I think those are most of my comments. I guess there's perhaps a it depends on how you define what's supposed to be in the baseline document. I guess I would have preferred to see some more of your detailed thinking and calculations from your presentation. I would have preferred to see a bit more of that in the baseline document to accurately characterize the hazard.
Sure.
I have just a question for clarification. The Iliamna deep clusters was brought up, and I'm not clear on, are those interface subduction or intra-slab? What kind of depth and type of earthquakes are those?
They go down in the sort of 100-mile range, I think, typically.
From like 80 down to 130 kilometers.
Yeah, I think they max out about 130, but they're not interface, no, and they're deeper down.
So the intra-slab?
Inside the slab.
Okay.
In slab, yeah,
Okay.
the intra-slab events, yeah.
Yeah, and there's a couple of different mechanisms observed, both strike slip and dip slip.
Okay. I have one other question, again, sort of clarification, but in describing these three main types of earthquakes, do you have you done or can you do some kind of probability analysis to say which one ought to be dominant for the Pebble area?
That has been done. I haven't done it myself yet, but one bit of information that is provided by the USGS is deaggregation of the hazard, where from that, for any given return period,
Talk to the microphone.
sorry, for any given return period event, what you can is do a deaggregation of the seismic hazard, and what that does, essentially without getting into the detail, it tells you what the relative contribution of the different types of earthquake or different sources were to that seismic hazard or to that peak ground acceleration at a certain return period. And this is something that we do look at, and it's something that does change. So a good example would be that for a very short return period, let's say a few hundred years, the interface subduction events would have a much larger contribution to the hazard than, say, a near-field shallow crustal earthquake. But as you go and stretch it out into several thousands of years, a 1 in 5,000, 1 in 10,000 year event, and look at the deaggregation information on that, you will see there's a bit of a shift, and now you get more of the hazard resulting from shallow crustal events nearby, and maybe some more in terms of intra-slab events, and less of a contribution from the interface subduction events. Not that that event goes away, but it's just relative contribution has changed.
Thanks. Jeremy.
Yeah, I had a couple of questions more about the transportation corridor, which we haven't really talked about yet. That seems to be a greater risk from two aspects. One will be, again, we talked about avalanche, landslides affecting that corridor, which might be triggered by earthquakes. But also there was some mention in the EBD about tsunamis being generated along the coastline there, seismogenic or volcanogenic. Is there any kind of probabilistic assessment of that? I mean, there was some mention that it might happen, but I didn't get much of a feel as to whether it has happened historically and what type of damage one might expect from tsunamis along that coastline.
Graham, can you speak in?
Sure. Personally, I haven't been involved in that sort of study. I have on other projects, but not on the Pebble project. And certainly, when, again, as you said, when you're looking at any sort of subduction zone, there is always a potential for tsunami generation in the region. And of course, there's also potential for tsunami generation in other subduction zones that could impact across the coast. But I haven't personally been involved in that, but that's maybe something that's considered in the future.
But does the EBD actually evaluate any evidence for tsunami deposits, for example, along the coastline? I didn't read anything about that. But it was certainly a recognized and mentioned risk.
I'll just make a couple comments on that since this is something I worked on previously. The Tsunami Warning Center has the responsibility for issuing tsunami information around the state, and they're generally not concerned about Cook Inlet because the water depth is pretty shallow. So a big tsunami requires deep water, and parts of Cook Inlet are quite shallow. There was some information in the report about volcanogenic tsunamis associated with sector collapse of Augustine. And that's a well-known mechanism for producing waves in the ocean. But the same thing holds, that the water depth around Augustine is pretty shallow. Now, there are some anecdotal reports of waves being generated during the 1883 eruption of Augustine. But if you dig into that, it's pretty hard to substantiate the accuracy of those reports, and then there's not necessarily real good evidence for tsunami inundation. So, like in Niskin Bay, for example, there are no tsunami deposits in the tidal muds in that bay. And I went in there specifically trying to find evidence for 1883, and I had the 1912 Katmai ash as a marker, and there was no evidence of anything below it. So I concluded that there was no wave in there, at least one that produced a deposit.
Anything else from panelists?
We can go to break. We're a few minutes ahead of schedule, but we can go to break.
So let's go ahead and do that. We'll go ahead and take our break now and be back in about 15 minutes. Thank you. Yeah, after the break, we'll have questions from the audience.